Hello, Honors Pre-Calculus students, Mr. Guzzato. Today's learning target is to understand and apply the circular definitions of trig. So you may know the unit circle, and you know that the sine refers to the y value, the cosine refers to the x value, and the tangent is the y value over the x value. And then the cosecant, secant, and cotangent are the reciprocals of sine, cosine, and tangent, respectively. But more in general, if you were not in the unit circle and you had some generic angle, let's call it theta, and some generic point x comma y, the circular definitions are the following. The sine is the y coordinate over the radius. The cosine is the x coordinate over the radius. The tangent is the y coordinate over the x coordinate. And then the cosecants are still the reciprocal. So r over y, r over x, and x over y. So we could generalize this, and if r is 1, then you will have the unit circle. You always could drop the altitude. And if you were to label x and y, you always could think of the Pythagorean theorem to get the radius. One thing that students make mistakes on is they sometimes forget the negative depending on what quadrant you are in. So let's take a look at a couple examples. So if you look at example 2 and 3, and I did change problem number 3, so if you're looking at the PDF version or the CAMI version, I did change the point for problem number 3, so please make note of that. For problem number 2, we want to find the 6 trig values. So what I like to do is I draw a picture. You don't have to draw a picture, but I like to draw a picture. The x value is -6, and the y value is 4. So here's the point, -6, 4. I always drop the altitude. So this distance is 6, that distance is 4. In my picture, I don't put a -6 because it's the side of a triangle, but I do want to make note that it is a negative x coordinate. So then I use the Pythagorean theorem to get the radius. So r squared is equal to -6 squared plus 4 squared. And when you do that, you get r squared is 52. So r is the square root of 52, which breaks down to 4 times 13, which is 2 root 13. So then using the definitions we talked about above, this is the angle of theta. The sine of theta is the y coordinate over the radius, which then is 2 over root 13, and you should rationalize root 13 over root 13, so 2 root 13 over 13. The cosine of theta is the x coordinate, so -6 over 2 root 13, -3 over root 13. Again, rationalize. So -3 root 13 over 13. The tangent of theta is the y coordinate over the x coordinate, so 4 over -6, or -2/3. And then the other 3 functions are reciprocals. So the cosecant of theta is the reciprocal of sine, so I just highlighted this yellow value. So the cosecant is root 13 over 2. The secant of theta is the reciprocal of cosine, so I just highlighted this green value. Therefore, the secant of theta is root 13 over -3. It doesn't matter where you put the negative for clarity. And then the tangent of theta we know is -2/3, so that makes the cotangent of theta -3/2. It would be my suggestion you pause the screen and complete problem number 3 with that yellow point. So if you take a look at problem number 3, I drew the diagram, used Pythagorean theorem to find the radius, and then in blue I have the sine, cosine, tangent, cosecant, secant, and cotangent. The most common mistake is people forget the negative sign in the sine and cosine of theta, along with cosecant and secant. Let's move on to the next problem. If you look at problems 4 through 7, they're all very similar. By definition, the radius is always positive. So for problem number 4, we're saying where is y greater than 0 and x being less than 0. So if you think of the quadrants 1, 2, 3, and 4, where is x less than 0 and y positive? The answer would be quadrant 2. If you look at problem number 6, the tangent is positive, so that means the y over x is greater than 0, and cosine is greater than 0. Well, cosine refers to the x value, so x is greater than 0. Now technically it's x over r, but as I mentioned, the radius is always positive. So this is saying the x is positive, and the y must also be positive, since x over y is positive. So what quadrant must you lie in if x is positive and y is positive? For number 6, you have to lie in quadrant 1. It'd be my suggestion you pause the screen and try problems 5 and 7. So for problem number 5, this is saying r over x is less than 0, which is really simply saying x is less than 0. And then cosecant is less than 0, so r over y is less than 0, which is really saying y is less than 0. So where is the x less than 0 and the y less than 0? You have to be in quadrant 3. For problem number 7, we're saying x is less than 0, and then y over x is less than 0. So if x is less than 0 and y over x is less than 0, this is really saying y has to be positive. So where is x negative and y positive? That must be quadrant 2. So number 8, the cosine of theta is negative 1/3 and the sine is positive. So where is the sine positive? The sine refers to the y value. So you're in quadrants 1 or 2. But the cosine here is negative. So where is the cosine negative? The cosine is negative in quadrants 2 and 3. So you have to draw the picture in quadrant 2. So I'm going to draw the picture. The cosine, remember, is the x-coordinate over the radius. So I'm going to write that down at the top. The cosine is the x-coordinate over the radius. So when I go to draw my picture, and if I were to drop the altitude, I know the x is 1, the radius is 3. In fact, because of similar triangles, if you prefer, you could say the x-coordinate is 1/3, technically negative 1/3, and the hypotenuse is 1. Trig is the ratio of similar triangles. I tend to use the top one, so then I'm going to use the Pythagorean theorem. So then the y-coordinate is going to be 3 squared minus 1 squared. So then y squared is equal to 9 take away 1. Y squared is equal to 8. So y is 2 root 2. So that's 2 root 2. Now I have the coordinate. So the coordinate is negative 1, 2 root 2. At this point, you should be able to find all 6 trig functions like we did a previous problem. Here's the angle theta. So the sine of theta, remember, is the y-coordinate over the radius, so 2 root 2 over 3. We already have the cosine of theta, but I'm just going to write it here for completeness. The tangent of theta is the y-coordinate over the x-coordinate, so negative 2 root 2. The cosecant is the reciprocal of sine, so 3 over 2 root 2. And then you're going to rationalize by multiplying by root 2 over 2. So 3 root 2 over 4. The secant of theta is going to be negative 3. And the cotangent of theta is the reciprocal of tangent. So the reciprocal is going to be, write this down, it's going to be 1 over negative 1 over 2 root 2. Again, rationalize. So negative root 2 over 4. It'd be my suggestion you pause the screen and try problem number 9. If we look at problem number 9, we're told that the tangent of theta is negative 7 over 24. The tangent of theta is the y over the x. So where is tangent negative? Tangent is negative in quadrants 2 or 4. We're also told that the cosine is negative. So where's the cosine negative? Quadrants 2 and 3. So for this particular problem, we have to draw the picture in quadrant 2 because that's where the overlap is. Now if the tangent is the y over the x, we know that that is negative 7 over 24. So the x-coordinate is 24 and the y-coordinate is 7. And if you think about it, the x-coordinate is actually the negative here. So this is the point. If you drop the altitude, you got 24 and 7. Using Pythagorean theorem, you're going to get the radius to be 25. So at this point, you can say the sine of theta is the y-coordinate over the radius, 7 over 25. Cosine of theta is the x-coordinate over 25. We already know the tangent, but I'm going to rewrite it for completeness. Then the cosecant of theta is the reciprocal. The secant of theta is the reciprocal of cosine. And the cotangent of theta is the reciprocal of tangent. Let's take a look at the next problem. If you look at problem number 10, it says the secant of theta is negative. So secant, remember, is the x-coordinate. So x is negative, which puts you in quadrants 2 or 3. The tangent is y over x, and the tangent is negative. So using the idea of the secant, you have to be in quadrant 2 or 3. And since the tangent is negative, you again have to be in quadrant 2. So when you draw this picture, you are in quadrant 2. So if I were drawing it, the secant of theta is the radius over the x-coordinate. So the radius here I can label root 13, and the x-coordinate is 2. Again, I do not put a negative in the triangle. And then you could use Pythagorean theorem. So root 13 squared is equal to negative 2 squared plus the y value squared. So 13 is equal to 4 plus y squared. Y squared is equal to 9. So y is 3. Now technically it's plus or minus 3, but here since the y coordinate is a positive value, I'm just going to write it as 3. At this point you should be able to figure out all 6 trig functions. So the sine of theta is the y coordinate over the radius. And if you rationalize, you get the following. The cosine of theta is the reciprocal. So cosine is going to be negative 2 over root 13. Again, if you rationalize, you'll get the following. The tangent of theta is the y-coordinate over the x-coordinate. Cosecant is the reciprocal, so root 13 over 3. We already have the secant, but I'm just going to write it down here for completeness. And then the cotangent is the reciprocal of tangent. I would pause the screen and try problem number 11. If you take a look at number 11, you can check your answers down at the bottom. Now the way I came up with that, the cosecant is negative, which means I'm in quadrants 3 or 4. The cotangent is negative, so that tells me I have to be in quadrants 2 or 4. The overlap puts me in quadrant 4. So when I label my diagram, the hypotenuse is root 5. The y-coordinate is negative 1. I use the Pythagorean theorem to get the x-coordinate to be 2. And then you can see the answers down below using the definitions that we talked about at the beginning of class. I hope you found this video helpful.